Hello. Can you guys hear me? Great. Yeah. And good afternoon, Amsterdam. And my name is Shumo. I'm a co-founder of Manta Network. And today I'm going to talk about how Manta brings composable privacy on the .sama ecosystem. All right, so just a little bit introduction myself. I'm a co-founder of Manta. I did a graduate school at the University of Washington, then kind of moved to Algorand as a research scientist, then spent like a 1 year time at UCSB as an assistant professor. Now I'm full-time at Manta. Yeah, please follow me on Twitter if you can stand my endless rant. Yeah, so I was doing some compiler research for zero-knowledge proofs. And then I find the best place to apply this zero-knowledge proof system is actually on a blockchain, right? So that's what we're building on Manta. So first, what is Manta, right? I think Manta is just a privacy layer for all the Web3 applications. We have a pretty long vision and a pretty big vision too. But let me just tell you our kind of vision stage one. So first, we would love to build Manta on the DOT and Sama ecosystem, right? So the first question we ask ourselves is that which kind of ecosystem we choose, and we choose Polkadot and Kusama ecosystem. And for several very good reasons, right? First is that it has a very high performance consensus. The way we view Polkadot and Kusama is that you have a truly decentralized high performance relay chain that provide excellent security, and you can have this kind of a parachain protocol, kind of like a dynamic sharding mechanisms to provide security as a service to all the parachain builders. And also, it has a very high performance WASM runtime, and this is very crucial to us, right? For example, if we are trying to build this kind of stuff on EVM, there's a logo, because just because EVM is too slow, right? And third, so we have this kind of very awesome native cross-chain communication mechanism, XCM, allows a high throughput, low latency, also very rich features cross-chain communication mechanism. So the kind of analogy I kind of always give to people is that thinking of the bridge is just like a token transfer, but XCM you can do more, right? Essentially, XCM my analogy is kind of like RPC in terms, instead of just sending dumb tokens back and forth, you can do more rich features in XCM than any other kind of a cross-chain communication mechanisms, right? Last but not least, right? Basically, substrate framework give us a very modular and very powerful framework to do what we want in a relatively short time, right? This is saving developer time as well, right? And so let me show you the first kind of product we're building called MantaPay. So the idea here is that we call it BYOT, like bring your own token private payment, right? So before I talk about that, let me kind of briefly review what is kind of like a privacy product on the market, right? So the first kind of privacy product is that you're running a privacy payment as a separate chain. So I probably all of you or some of you have heard of private cryptocurrencies like Monero or Zcash, right? But the problem with this kind of a product is that you have to use the kind of their native currencies, right? And it's a single asset protocol, and the usage is not very wide, right? Because essentially, we are a firm believer of a permissionless system, right? Everyone have their own tokens, right? We just want to privatize whatever your favorite tokens. It could be Dogecoin, it could be Polkadot, right? Yeah. So, but how does this thing work, right? So first, let's say you have some public crypto tokens. First, let's say Kusama, Ethereum, and Bitcoin, right? Ethereum, Bitcoin, we need to build bridges, but right now we already built products that can support .sama ecosystem tokens. And what do you do, right? So you just click a button, literally just click a button. Then your asset will be, we call it mint, or converted to a private asset. And this private asset are held in this so-called shielded addresses, right? And by this after this convert to private, you can actually send to your friend and do a bunch of other things, right? So basically, all the transfers between the shielded addresses are shielded by zero-knowledge proofs. And let's say you can also reclaim it back to the public tokens and do your favorite activities, right? So, so let's see how it works, right? So this is the Manta architecture. So like at the bottom layer, right, Manta is a parachain, and we build a parachain runtime. So on this parachain runtime, we have a palette called MantaPay. So what does MantaPay did is that we actually deploy a zero-knowledge proof circuit, which is MantaPay circuit, using ZK Snark within this palette. And this circuit will generate a zero-knowledge proof verifiers. So how does the transaction goes, for example? So for example, when you download our Manta client, which is Manta ZKP signer, so whenever you send a transaction, so this Manta ZKP signer will generate zero-knowledge proofs. And we call it Pi transfer. And this zero-knowledge proof is being verified on-chain using the ZKP verifier. So you can see here, right? Because instead of just sending a public text, like plain text transactions, we're actually sending a ciphertext here. And because the zero-knowledge properties of zero-knowledge proofs, and this, the transaction is shielded. So in the sense that the blockchain verifiers just need to verify the zero-knowledge proof instead of executing the plain text transactions. So whatever data you kind of leave on-chain is private, right? I think this is in our view, this is the only way you can do meaningful privacy, because at the end of the day, you want your on-chain data to be private. So that's a MantaPay architecture, right? So I want to say we're actually working very hard to ship the Manta zero-knowledge proof signer as a WebAssembly module, so that all your favorite wallet, for example, MetaMask, Talisman, and many others, can just like seamlessly integrate the MantaPay without you having to download the signer. So I think what's great about Manta is for us, we are really kind of like a DOT and Kusama ecosystem enabler, right? So we're not really competing with any chains, but we want to add functions to your favorite parachains. So for example, right, like you can see like a Manta plus Moonbeam will have like a private ERC20 and private XC20 asset. We actually did a XCM test with Moonbeam last month, right? For example, Manta with Akala, you can have like private stablecoin. And Manta with Interlay, you can have private BTC. And Manta plus Fala, you can have like a private e-commerce. You can privatize your on-chain data using Manta and privatize your off-chain computation using Fala, for example, right? Yeah. So So next, you might ask, like, what's next for Manta, right? So our first step is using like XCM to support all the Polkadot Kusama ecosystem assets. What's going to next is that we are going to enable like decentralized cross-chain bridges to bridge all the assets from other chains, for example, Ethereum, Avalanche, Polygon, like Binance Smart Chain, to basically enable privatization of the assets for all the Web3 space. Yeah, we can privatize like fungible tokens. We can privatize NFTs. So actually, as we're speaking today, the team is working very hard to launch the second version of the testnet with a lot of new features. And also, we actually streamlined our zero-knowledge proof generation process. The zero-knowledge proof generation is 10x faster than the first generation. Yeah, our like applied crypto team did a lot of hard work to make this happen. So this testnet v2 is not launched yet, but will be launching in 2 to 3 days. Yeah, please go and check. Really, like, also this testnet v2 is deployed on Rakuku. So like any like a parachain team members, if you want to test, like if you have a parachain like runtime deployed on Rakuku, and also want to test, like starting test, privatize your parachain asset, just find me and we should talk. Yeah, so this is a like dramatically outdated figures. So we have run testnet about 3 months. So this is a figure I actually captured about 1 month ago. So actually, we have more than like 60,000 transactions happens in the testnet, and about like 27% are private transactions. And you can see here, right? So this is actually right now is the most high performance, even as a testnet. This is the most high performance private payment system on Earth, right? For example, give you an example, like in the last 3 months, we actually processed, even in the testnet, processed more privatized transactions like than Tornado Cash in the whole year, for example, right? So that's basically our first step of our vision. So yeah, so let me briefly tell you we get a testnet 1.0. So for the testnet 2.0, all the exciting new features we are super excited about. Yeah, just forgive me, I can like just do this non-underneath, right? So first is that in the previous version, we are like have one-time address. In the testnet 2.0, we have a reusable address. Basically, imagine that you are like an artist. You want to post your shielded address online for people to send you patrons, and you want to keep your privacy, you can use Manta to do that. The second is that we have a concept called viewing keys, right? So viewing keys basically can be used to selectively disclosure for regulation compliance. So for example, if you have this Manta shielded address and you want to report to government about your taxes, right? You can show these viewing keys to the government can see all your transactions. You still won't lose your privacy. Also, whoever has the viewing key can only view the transactions, cannot actually spend the transactions. And of course, we have like a 10x more performance in terms of zero-knowledge provers. Last but not least, I can briefly tell you the zero-knowledge proof system that powers Manta. Right? Basically, we're using so-called like a second generation zero-knowledge proof system called Plunk. So the idea here is that it's a universal snark, and it actually enables you to do a lot of customization in terms of the kind of like a zero-knowledge circuit gates, so that for an experienced team like us, right, so we can leverage these kind of advanced features of customized gate to optimize the zero-knowledge performance so that the user has a better user experience, right? So last, I want to show you all the like awesome team members. Again, this is a little bit outdated member list, but I want to say we are hiring. We are hiring in all kind of specialties like front end, full stack, Rust engineers, applied crypto, and DevOps. Right? I think that's the end of the talks, and would happy to like answer any questions if you guys have any. Please.
You want to talk about, so you said that you can integrate by XCM, right?
Right.
You want to talk about how you do the account matching, right? There will be accounts in the original chain, maybe Ethereum accounts, and then maybe you have a different type of accounts on your chain, and how that works. Maybe it's technical.
Yeah. This is a good question. So how does the cross-chain account works? So it really depends. So at the end of the day, what matters is that, for example, Ethereum and Polkadot, right? So despite the crypto is different, right? The mnemonic standard is the same. It all using like I forget which BIP is, right? BIP, maybe BIP 44, right? All use like 12-word mnemonics in the sense that the root secret format is the same. You can do a mapping of the public account from your like Ethereum account to a Polkadot account. We're actually going to directly support Ethereum accounts in our chain, right? So that's very easy. For a Bitcoin, for example, you can kind of using the same trick. It will be a different account, but there is a direct mapping here, right? So we just like write tools to help people to mapping here. And for I know there are some protocols, right, using a different kind of different kind of like a secret, like mnemonics, than this BIP. For example, like algorithm using like 24 words mnemonics, right? So then this kind of, you need to create a new account in this case, right? Because there is no kind of one-to-one mappings between the account. Yeah. So, but for most ecosystems, I think like most blockchain systems kind of adapt the mnemonic system by Bitcoin and Ethereum. So yeah, it should be fine. Yeah. All right. I think with that, I would end the talk here. Thanks for listening. Yeah.